Multiplication of decimals using the standard algorithm. 3 steps. Step 1, estimate. Step 2, multiply without the decimal points. And you can do that any of your multiplication ways. Step 3, use your estimate to place the decimal point. So let's do a few problems. Let's do 4 times 3/10. Let me write that so we can read it. 4 times 3/10. Now let's look at it first. I am multiplying 4 by a number that is less than 1. If I'm multiplying by less than 1, my product is going to get smaller. So my answer has to be less than 4. Now 5/10 equals 1/2, so it's going to be less than 2. So when I'm looking at my estimate, I know my estimate, my actual answer is going to be less than 2. That's my estimate because I'm multiplying 4 by less than half of it. If you multiply by less than 1, my number is going to get smaller. So then step 2 is multiply without the decimal points. So then I just have 4 times 3. And I get 12. My estimate. If I put it here, it's 12/100ths. If I put it here, it's 1 2/10. If I put it here, it's 12. Well, we said it was going to be less than 2. And we have 1 2/100ths. It's repeated addition, so I can check it. And I would get 12, so 1 2/10. Follow the steps. Estimate, multiply without the decimal points, and use your estimate to place the decimal points. Now we have 1 8/10 times 0 5/10. My answer is going to be smaller than 1 8/10 because I'm multiplying by less than 1. So it's going to be smaller than 1 8/10. Actually, 5/10 is a half. So my answer is actually going to be half of 1 8/10. So now I'm going to multiply my estimate. It's going to be half of 1 8/10. It's going to be less than 1 8/10. I'm going to multiply without the decimal points. So I have 18 times 5. I end up with 90. It has to be less than 1 8/10. It's going to be half of 1 8/10. So if I put my decimal point here, it's less than 1. If I put it here, it's 9. If I put it here, it's 90. So it's going to be that, 9/10 or 90/100ths. Because I said it's going to get smaller, and 9 is half of 18. So that's how I came up with placing my decimal point there. 6 8/10 times 0 6/10. All right, again, I'm multiplying 6 8/10 by something less than 1. If I'm multiplying by less than 1, that means my answer is going to go down. It's going to be less than 6 8/10 because it's going to be less than 1 because I'm multiplying by less than 1. So 6 8/10 times something less than 1 is going to get smaller. Now 6/10 is more than a half, so it's going to be more than half of this, which would be 3.4. So it's a little more than 3.4. I multiply without the decimals. So I have 68 times 6. I don't need to put that 0 in the front because if I put a 0 there, it doesn't do anything except make more work for myself. 6 times 8 is 48. 6 times 6 is 36. Plus 4 is 40. And my answer, I said my estimate would be a little more than half of this. So it's going to be 4 8/100ths. 4 8/100ths. let's look at one and 6/10 times 2 and 4/10. Now this time, our answer is going to be bigger than 1 and 6/10 because I'm multiplying by a number greater than 1. So if I just looked at the whole numbers, 1 times 2 would give me about an answer of 2, or 2 times 2 would give me an answer of 4. So I'm going to be somewhere in the 2 to 4 range. Now I multiply without the decimal points. So I have 16 times 24, 64, and I said my answer was going to be somewhere between 2 and 4, and it's 3 and 84/100ths. If I put it here, it's less than 1. If I put it here, it's 38. If I put it there, it's 384. So that would obviously be too big. So we follow these steps, estimate it. That really helps you with placing your decimal point. Multiply without the decimal points. So when you do the actual math, ignore the decimal points, get rid of them, sell them to somebody who's starving for decimal points in Ethiopia, and then use your estimate to place the decimal point where it goes.